is always the amino group, and we call this the N-terminal when we are doing the sequencing of proteins. And it always ends with a carboxyl group, so the end is called the C-terminal. So remember, in the synthesis of proteins, a polypeptide, amino acids bond to each other. Let us draw the final structure after the reaction. What you are going to see is a situation where the structure will now look like this. Amino group, this is the amino group there. Carbon, hydrogen with R1, that is the one there. Now, you used OH and H, so they will not appear in the final structure because you used them to make water. So there will just be a line connecting directly to nitrogen, and this nitrogen as H again continues like this, R2. Again, we used OH and H, so carbon will bond directly to nitrogen, and then we are going to have C, H, and then carboxyl group at the end, and this is R3. This is our final structure, and the bond linking them, the first amino acid to the next one is this one I'm circling here. Even here, the bond linking this amino acid, this one to this one, is this one. And the name of this bond that links amino acid is what we call a peptide bond. So the bond between amino acids as you make a polypeptide, which is a protein, is simply referred to as a peptide bond. So you should remember that we can name the peptide bonds. When you create one peptide bond, we simply call this one monopeptide. Monopeptide simply means one peptide bond. If you have two, dipeptide, 3, tripeptide, 4, tetrapeptide. So, you should remember the fact that for you to make a monopeptide, you need 2 amino acids, not 1 amino acid. I know the name is mono, so most students are tempted to think because it's mono, you need 1 amino acid. No, you need 1 amino acid here sitting next to another. That's when there will be 1 peptide bond. So you need 2 amino acids to make a monopeptide, which is 1 peptide. To make a dipeptide, you need 3 amino acids. One will be there, another one there, another there. Then you have 2 peptide bonds. So that is how we use amino acids to make a protein. And the structures of proteins, which we shall look at later, this is my next discussion, will base on what I have explained here. It doesn't matter the number of amino acids that you are using to make a protein. The reaction is the same. There is always liberation of water when you are linking amino acids together. And there is formation of a peptide bond. So my next discussion is classification or groups of proteins. What are the different groups of proteins that we have? I think we discussed this in secondary school, so it won't be very difficult for us. This is something we talked about all the time. I know you know them, but what will happen right now is that we shall state the groups. When we state them, we shall define them and give examples of proteins in each of the groups where possible. So we have 4 groups of proteins. The first group of proteins is called a primary structure. And I'm going to use the whole board in order to show you the 4 groups. The next groups, the group of proteins that we talk about is what we call a secondary structure of a protein. The third group is tertiary structure of a protein. And lastly, we have quaternary structure of a protein. So, quaternary, tertiary, secondary, and primary. You should remember something very important before I go into the details. The order in which they are determines the complexity. So this one is less complex than secondary, and secondary is less complex than tertiary, and tertiary is less complex than quaternary. So this is smaller than secondary. So let us discuss them in details. I'll start with the primary structure. Previously, I have explained to you how we get amino acids. We link them together in order to make a protein or a polypeptide. For the sake of time, I'm not going to draw amino acids throughout. I'll be using circles. So when you see me drawing a circle and another one, I do this. In your mind, you should remember that I'm trying to show you one amino acid which I can call A1 and another amino acid I can call A2 coming together, and that bond there is what we are calling a peptide bond. And from my previous explanation, you should remember that the end is always a carboxyl and the beginning is always the amino, the N-terminal and the C-terminal. So, having said that, let me explain to you what a primary structure is. A primary structure of a protein is simply a sequence of amino acids linked in a straight chain. And what links them is the type of bond that we call a peptide bond. If I am to use circles to demonstrate, it simply means that you started with the amino group, and we have this amino acid, the first one, linking to another one, linking to another one, linking to another one, linking to the other, until at the end, what you have is the carboxyl group. So, C-terminal and N-terminal. What do we have at the middle? Successive amino acids linked together through what we are calling a peptide bond. So this is a peptide bond, peptide bond, peptide bond, peptide bond. When you see a protein is simple like this, just a sequence, no shapes whatsoever, this type of protein is what we are calling a primary structure of a protein. How does it differ from a secondary structure? This one differs from a secondary structure in that in a secondary structure, the protein tries to coil, to turn, and even to form sheets. So a protein coils, turns, and forms sheets under secondary structure. So it's a little bit advanced. It's not just a straight chain. And the type of bonds that are found under secondary structure, it doesn't only have a peptide bond, which was found at primary, it has also hydrogen bond present. Let me try to draw them so that you understand. An example of a coil that is formed at secondary structure is what we call alpha helix, which looks like a coil with an imaginary axis. Although I'm using a single line, I want you to remember that it's just like this one, only that it's a coil. What does it mean? It also begins with amino group and ends with carboxyl group. But in the middle, there are proteins linked through peptide bond, although it's forming a coil. Now, What is linking the amino acids in this coil is the same bond that linked the amino acids under primary, which is a peptide bond. And in addition, as this coil forms the alpha helix, to stabilize it, there is a reaction that occurs between the NH group and the carboxyl group of one amino acid and the next amino acid in order to form what is called the hydrogen bond. So hydrogen bonds comes there in order to stabilize the ring so that it doesn't dismantle. So in addition to peptide, we have hydrogen bond. That is how it forms coils. And you can see that for it to form a coil, it had to make some turn somewhere. It turned. That is why we are saying there is turning in secondary structure. What about sheets? How are they formed? The sheets we are talking about, they are formed in two ways. One starts like this. It quite alright starts with the amino group and forms a structure like this, a turn like that, and then ends with a carboxyl group. Or might start with the amino group quite alright, forms a chain like this, turns, but its structure looks like this. I know this is a little bit confusing. What is the difference between structure number A and the structure number B?